So in a given problem, there are two overhead lines P and Q which are connected in parallel. So those two lines are supplying 10 megawatt at 0.8 power factor, and also is given the resistance and reactance of the individual lines, and is asking how much is the real power supplied by the line P. So there are two lines. This is line P and this is line Q. This is P and this is Q. These two lines are connected in parallel. So they are supplying a load of 10 megawatt at 0.8 power factor lagging. So this is P. I'll put here, this is P line and this is Q line. So for P, the resistance is given as 3 and reactance is J4, and here this is resistance is 4 ohms and reactance is J3 ohms. Okay, so Zp equal to 3 plus J4, this is equal to 5 at an angle of 53.13, and Zq equal to 4 plus J3. The magnitude is same, but the angle is 36.87 degrees. So since these two are connected in parallel, the voltage across these two are same. So this is the real power P. What about S? S is nothing but 10 by 0.8 at an angle of minus 36.87 degrees. So this is equal to 12.5 MVA at an angle of minus 36.87. What about the current? This current I, total current. The total current I is nothing but S by V. Similarly, if I know the current I can find out IP and IQ. So I'll take this as IP and I'll take this as a IQ. So IP is nothing but the total current I into 4 plus J3 by 7 plus J7. Similarly, IQ is equal to I into 3 plus J4 by 7 plus J7. So IP by IQ is equal to 4 plus J3 by 3 plus J4. This is nothing but 5 at an angle of 53.13 by 5 at an angle of 36.87. So this is equal to 1 at an angle of 16.26. So that means IP is leading by an angle of 16.26 with respect to IQ. Okay. Now find out the Z equivalent. Z equivalent is nothing but 3 plus J4 into 4 plus 3J by 7 plus J7. So this is 2.5254 at an angle of 45 degrees. So once you know Z equivalent, you can find out the equivalent drop. So that is Vs minus Vr, that is the drop equal to Z equivalent into I. So Z equivalent is 2.5254 at an angle of 45 into the current is nothing but I at an angle of minus 36.87. So this is equal to 2.5254 I at an angle of 8.13 degrees. So once you know this drop, you can find out IP now. IP equal to 2.5254 by 5 into I at an angle of 8.13 minus 53.13. So this is equal to 0.5051 at an angle of minus 45 degrees. So now the power through the line P equal to V into the current is 0.5051 at an angle of minus 45. This is nothing but I have missed here 5051 into I, here also I. So since he is asking, for example, if it is active power, then it will be only real part of this. So that is nothing but V into 0.5051 into I into cos of 45 degrees. So this is equal to V into I into, I will divide and multiply with 0.8 into 0.5051 into cos of 45 degrees. So this Vi into 0.8, this is nothing but the load, that is 10 megawatt. So this is equal to 10 by 0.8 into 0.5051 into 1 by root 2. So if you simplify this, you will get 4.465 megawatt.